All right, it starts today's class. So today is about ROP. I hope you already watched the video, and you did? Nice. So I think this module is actually easy. It's much easier than kernel module, than the last module. I think it's kind of like as easy as race condition. I see some of you are shaking your head, but it's not a bad thing, actually. This means that it is supposed to be easy. It means that if you feel it is hard, there might be just like a little tiny stuff that you're missing right now, and all you need just like a click. So like I can talk about that real quick, and then you will. I hope that today's lecture will help you understand how ROP actually works. I mean the concept it is indeed very easy. So don't worry. My point is that don't worry too much about that. Okay. I guess we can do the following. So, since some of you are nodding your head, shaking your head, so I am going to talk about how kind of ROP works in general, just kind of a repeat of the video. I hope that giving you more like diagrams or illustrations will make you better understand like the ROP chain, things like, just to have a better concept in your mind. But hopefully I can walk through this real quick, say like 10 to 15 minutes. And in the meanwhile, for those that already understand the ROP, like the layout of the stack when you construct a ROP chain, so you can keep working on the challenge. And then after that, I will go through level 1, 2, 3 very quick. I'm not going to show you how to do that, but just like go through that very quick. Because I think that the first 3 levels are rather trivial as long as you understand the mechanisms of ROP. Okay. And then I will give you more time to work on level 4. And in the meanwhile, if you are already working on something beyond level 4, you can also continue to work on that. And if you have any questions about any of the levels, you can send me the message on Twitch or Discord now, and then if I have time today, I will cover some of them. If not, I will talk about them on Wednesday. Okay? Cool. All right. So let's go take a look at the ROP. So I'm gonna use the slides that I have for 5:45, but I think that the concept, the knowledge itself is pretty much the same. So just walk through this real quick. So I think maybe the best way for us to start, talking about ROP is actually doing a little bit backward. Like before we talk about ROP, let's first talk about how stack works when a function returns. Okay. So this may feels like you're writing back to when we talk about shellcode, things like that, but we've never been through this detail, like to look at instruction by instruction and check how the stack looks like after each of the instruction is executed. So let's start from there. Okay, so let's consider the scenario. In this case, we are at function foo now, and function foo is just about to return, okay? And the function foo was called by bar, okay? So function bar calls function foo, and the stack on the right-hand side is the current stack frame for function foo. So consider that right now, the program is executing to the point that function foo finished this printf statement and is about to return. Okay? So does this make sense? The current scenario. Okay? If not, ask me right now, and I'm happy to repeat. Okay? So right hand side is that this is the current stack frame for function foo. Okay? All right. So by the time that the function foo returns or that finishes, it will call 2 instructions. One is leave, and the other is return. Okay? So what's going on? How does this, stack frame got addressed? How does this stack got changed after these two instructions are called. So the first one is leave, okay? So leave is identical to two instructions, okay? One is move. RSP RBP means that you move the value from RBP to RSP, okay? And then the second is pop RBP, okay? So going through this, so this is originally where the RSP is, RBP is, right? This is the low address and this is the high address. And if you remember, we always have the saved RIP at RBP plus 8, right? So you should be already very familiar with the location of the saved RIP, which in this case, it's somewhere that points to the start of printf, right? So because this is bar and bar calls full, after full's return, it will continue to execute printf. Okay, cool. All right, so leave again. So it will first move RSP RBP, right? So then now means that RSP's value will be equal to RBP, right? Because RBP's value got transferred to RSP. So that's why now if you look at the stack frame, you'll find that RSP and RBP, they point to the same location, which is the same saved RBP, okay? All right, cool. And then the second is pop RBP, right? So the pop RBP means that you are going to pop this value up, right? Because now RSP, which always points to the bottom of the stack, will pop up this value. And then also give this value to RBP, right? Cool. So that means that your RSP will be shifted, right? RSP will be shifted just one element down or up, like just like, you know, the address, the value of RSP will be plus 8, right? Because now it's going to point to the saved RIP location because of pop, right? Pop is a stack operation based on RSP, the bottom of the stack. Cool. And then because of the saved RBP's value will be restored to RBP. So that's why you will find that RBP is pointing to the previous stack frame, right? Because this is what is saved. So this RBP starts to point to the base of function bar. So after leave, we have RSP is actually pointing to the saved RIP place. And RBP got restored to the previous like function bar's base function base frame. Okay, cool. And then the next is going to be return, right? So return means that you want to pop the value. So it's like it's equivalent to pop RIP and then jump to RIP. Okay, so pop RIP means that we have RBP, right, like added by 8 again, right, because we pop, right? This is a stack operation. And then also RIP will be equal to this value, which we store on stack. Okay, so we pop RIP, so RIP got to the saved RIP's value, and then we jump, right, using like based on the current value of RIP, we jump. So that's why the program will go back to printf. And the stack frame got restored, right? So it's like now we go back to the stack frame for bar. RSP is pointing to the bottom of the stack. RBP is pointing to the base of the stack. And also RIP is pointing to the instructions of bar followed by function full. Okay, so this is how function return works. Okay, cool. Yes.
So when
question.
RBP pop, it will just like reset to the base, or like.
Yes. So when RBP got pop, I mean, in general, pop it just means that you look at the stack, right? You have the stack, and here we go. So you look at the bottom of the stack, right? You just retreat that value out and give that value to RBP. Right, so that's exactly what pop RBP does. And also because you shift the stack, right, because you pop the bottom of the stack, RSP, which is the register, which always points to the bottom of the stack, right? So that's why RSP's value also got changed, okay? So yeah, so keep in mind, like whenever you have a pop, it means that you change your RSP's value plus 8, right? And also, depending on the other operand of the pop, you will move the bottom of value to that register. Okay, cool. All right, so now let's start to talk about return. Okay, so now we can forget about leave, we can forget about RBP, and only look at return. Okay, and if you remember, when we say return, it means pop RIP and then jump to RIP, right? So two equivalent instructions. So if you look at return, this is how it looks like before the return instruction was called, right? RSP, which is the bottom of the stack, is actually pointing to the saved RIP, okay? The saved return address. So we pop RIP, right? So it means that we shift the bottom of the stack, we give this value to RIP, and then we jump, right? According to that value, right? So this is how it looks like for the return. So a single return instruction will just look at the bottom of the stack, check the value there, and give that value to RIP, and then jump there. Okay, it's very simple. Okay. Then what about we do two returns together? Okay, so we do one-time return and the return again. How the stack will look like, right? So let's try that. Suppose this is the stacks, right? You can forget about RBP, only look at RSP and then those values. Okay, so the first time that we call return, RSP will shift this value, will give it to the RIP, and then it'll execute something, right? Okay, cool. And then now, the second time that we call return again, RSP will just repeat, right? Which is go again, right? Shift again, and then use that address as the second RIP's value and execute there, right? So this is how it looks like if we call return. Okay, so just like check the element. So, and then if you look at the stack, the first element will be just the first to save the return address, and the second will be the second return address, and that's it. Okay, so this is the way that you can put return together, or you can chain things together. And because of this, now we start to insert something in the middle of this two return instruction. Okay, so say that we have saved RIP. The first save RIP points to something. It has a move instruction and a return. Okay, so now when we do the first time return, this saved RIP will make the RIP goes to those instructions, right? So that means that after the first return, our program will start to execute this move instruction and the return, right? So after doing this move instruction, and then it calls return, right? And then keep in mind that right now after this, so our RSP is already pointing to this location now. And then because of this return, right, it will consider this location as the second return address, right? And then because of that, it will then execute call. And then by the time that it executes call, the RSP will point to the next place. Okay, does this make sense? Cool. Okay, this is very nice. So if we start to understand this, then things are getting easier. So this is the so-called a ROP gadget. Okay, so, and also this is why we call it return-oriented programming, because everything, like every gadget, is kind of end with a return, which guarantees us that we can use this chained in fact to go to the next place. So that's why we call it ROP chain. So we just like chain those gadgets. So every element is called a gadget, which normally ends with a return. Okay, yes, question?
Why do we need to add the move RDI? Is it necessary?
It's not.
RTRT?
Question, why do we need to add this move instruction? So it's not necessary. The reason why we put the move or put whatever other operations there is because we hope that this can help us achieve our malicious purpose, such as to read the flag, right? So those return instructions can only guarantee us that we can execute something in sequence, right? But it doesn't give us any actual behavior, right? So that's why we want to put those like move instructions or the other instructions together so that we can do the malicious stuff that we want. And then using this return, we can jump to the next gadget and continue to do the stuff, right? The only reason why we have to have chain instead of like a shellcode, right? Or like jump to the places that execute something bad is because in normal world, in real world, it's going to be very hard for you to find a whole chunk of of code that execute exactly things that you want, such as read the flag, right? So you want to write something that can fulfill that purpose, right? So that's why you kind of like take a little piece from this place and then take another piece from the other place and then put them together.
So, like, for example, there's one open function in one function and another writes.
Mm-hmm.
So you need to make use of two.
Exactly. Exactly. Yes. For example, if you have one places that open a file and then the other places do write, then you want to like locate these two places and then chain them together using ROP chain. Okay. All right, guys, if there are no more questions, then let's step further a little bit by looking at how can we come up with a ROP chain potentially does execve bin sh. Okay? So suppose that we cannot find any of the places that can call execve followed by bin sh, like open a shell. There's no way that we can directly call it. Then can we come up with a ROP chain that can fulfill that? Okay? So in order to call execve with those proper arguments, what we need to make sure is that we want to have a system call, and then the RAX, the number of that system call, will be hex3b. Okay, so this is like system call of execve, number is hex3b. Okay, so we need to make sure that RAX is equal to hex3b. And then RDI, which represent the first argument, right? It has to be an address that points to this string, right? So it's a pointer pointing dereferenced with this string /bin/sh. All right, and then the first argument, the third argument, what am I talking about? The second argument, which is RSI, is null, so it's 0. And then RDX, which is the third argument, is also 0, okay? So that means that we want to make sure that RX, RDR, RSI, and RDX, these 4 registers have the exact value that we expect, and then we have a system call, right? Okay, so how can we make that happen? We want to chain our gadgets all together, and we can make each of the gadget to fulfill one of those arguments condition, okay? For example, we could do is that now I'm just like start to construct the chain, okay? So we can potentially make the first gadget or the first chain to fulfill the purpose of RX is equal to hex3b, okay? But it may be very hard for you to find exactly from the instructions that there is a specific instruction say move RX hex3b, right? So because that's very, very special, right? However, what you could do is that you can try to find a pop RX gadget. Because if you have a pop RX, by the time that you execute it, the instruction, the program will look at the stack, right? And then find that value and then pop that value to RX. Okay? Does this make sense? Good. All right. So then to make RX equal to hex3b, what we could do is that we find a gadget that does pop RX, and of course follow like ended with return, and we put this value of hex3b onto the stack. Okay, So let's try to execute. Let's try to just like simulate the execution. Okay. So suppose now we are at like I'm just trying to think how we're gonna start. Okay, so suppose that RSP is right now pointing to here, right? By the time that pop RAX will be executed, we know that RSP will point to right, like beneath the gadget address of pop RAX, right? Does this make sense? Okay, so it's right below that, right? Because that's how we do return. Like from the previous return, we match the jump to pop RAX, this gadget. Okay, and now we are going to execute pop RAX. So we execute it, we move RSP because again, this is bottom of the stack. According to the RSP, we shifted RSP, right? And then we pop that value to RAX. That's how we got pop RAX. And we make sure that RX is equal to 3B. Okay, good. And then the next is return, right? Again, return is equivalent to pop RIP and then jump to RIP, right? So now we're going to pop, right? And then we jump to the place that this location points to, which is going to be the next gadget. Okay. And now for the next gadget, we have pop RDI, right? And then for that pop RDI, below that pop RDI gadget, we will save the address of /bin/sh on the stack. Okay, so we do pop RDI, the address, the pointer of this string will be popped to RDI so that we make RDI's value equal to the address of /bin/sh. And then we do a return. And then because of that return, we'll go to the next gadget. Okay? So followed by that, we will be able to finish all the gadget and then we call system call. Okay? So yeah, so this is the way that you can chain those gadgets together and you will have a so-called ROP chain. Okay? I hope this is clear enough for you to understand how ROP chain works. Good? All right. Cool. Okay, let me check tweet real quick. So we will need to have to execute a gadget that put so the question here is that like in order, how can we make hex 3B here on the stack? The answer is that, this entire thing is going to be part of the buffer or part of the input that you overflow the stack. You overflow the buffer, right? So basically, this entire stuff is going to be your input. And the program itself will take this and store that on the buffer, or on the stack. Okay? All right. Okay. Now we have all this. And let's just go through a level 1 through 3 real quick. You will notice that the first one is similar to what you had done before. For buffer flow, you just need to overwrite the return address. The second one is the one without argument, I think. And then the third level is about you call a bunch of winning functions with specific arguments. Okay, so let's say maybe we start with level 3, I guess. Or maybe level 2. I don't know. I'm hesitating. Let's do level 2, actually. Let's do level 2. I think level 2 is more straightforward. Okay, so let's do this real quick. I will give you 5 minutes just to familiarize with the challenge. And then we're going to walk through this real quick. Okay, let's work on this real quick. So this challenge is pretty straightforward. It asks you to call two functions together, right? So you need to call win stage 1 and then win stage 2, right? So basically it asks you to put a very simple chain together, and according to the requirement, the first part of the chain will be calling, it will be the address of win stage 1. And then the second part of the chain will just be like the address of a win stage 2, right? And that's it, right? So it's a very simple challenge. Let me see, where am I? Okay, yeah, so I'm gonna just show this to you real quick. So you overflow the buffer, right? And in this case, in my case, this buffer will be to save the return address. It will be 120 bytes, and then after that, I just put, the address of the first function, which is win stage 1, and then followed by the address of the second function, win stage 2, right? And that's it. I think different people have different bytes. Yeah. Okay, is there any question? Good? Cool. Okay, so now I'm gonna ask you, which is gonna be something related to level 3. What if we have win stage 1 or win stage 2 followed by an argument? Okay, so it means like now you need to call win stage 1 and with an argument of 1. Okay, things like that. Right? So it's like you have to call win stage 1 by 1, and then stage 2 followed by 2 of 2. Okay, how to do that? To do that, then you have to first prepare, right, argument, and the second is call function, right? So that means that your gadget has to be, you first have, your gadget needs to be something that make your RDI is equal to 1, right? And then you call win stage 1. Right, and then you have your RDI is equal to 2, and then you do win stage 2, right? So this should be how the ROP chain look like, right? Okay, then the question here is, how can we make this happen, right? So we already learned that a typical gadget that we can potentially use, although I just want to say this is not the only solution, is that we want to find a gadget that can do maybe pop RDI, right? And then we put 1 there on a stack. And then we have win stage 1, right? And then we do pop RDI again. We have 2, and then we do win stage 2, right? Does this make sense? Okay, good. Okay, if there's no more question, then you can work on level 3 real quick now. I guess now you need to tackle is that how can you find the gadget pop RDI in your level 3? Okay, I am going to give you, say, 10 minutes to familiarize with level 3 and try to find a gadget, and then we're going to work on this together. Okay, let's work on this together. Have you solved this challenge? Yes? Okay. Do all of you solve the challenge? No? Still working on that? Okay. So, let's work on this real quick. So, right now we already have an idea of what we want to do, right? So, the idea is that the ROP chain should be like should start with a padding, right? You will have a different padding. You will need to overflow your buffer and then to the return address. And then after that, you want to call each of the function, right? Win stage 1 with 1, win stage 2, with 2, etc. Right? And now we already know that we need to do. So on my end, I have 5 functions to call. I don't know if it's the same from your end. Okay, same. Good. Okay. Yeah. So then we need to find this gadget. As we say, we hope that we can find a gadget of pop RDI, right? So that if we have that, then we can put RDI's value, and then we just call winning stage 1, right? And then etc. Okay, right? Awesome. So then I can do a very quick for statement. A 6, right? And then we can have it's supposed to be the gadget, and then pass this value p64. This is like the function if you have Pong using Pong library. So you'll have p64, which is to convert an integer to a 64-bit byte following the little endianness. Okay, and then plus the symbols, and then we can just put stage, right? So that means that if I already have my elf open, baby ROP level 3, right? So we have that elf open, then I can use elf.symbols to get the address of the specific symbol. And then now I'm just using a format string to specify like that's when stage 1 or 2 or 3 depending on the value of the I, okay, of the argument I, okay. And I want to set the context, so this is 64-bit. Okay, cool. All right, so now we need to figure out this getGadget function, basically, right? Because we want to find the gadget. So there are multiple ways, or I say multiple tools that you can find. So I am going to first show you one way, which is to use a tool called ROP gadget. I can't really install it from like onto the onto pwn.college. However, you can have that in your local machine. Oh, it is already? Oh, nice. So just like do ROP gadget. Oh, it is here. Nice. Oh, good. That's even better. So we can do ROP gadget, binary, and baby ROP. Cool. All right, so there is. Let me show this again to you to make it a little bit. So it is ROP gadget, binary, followed by the binary, and then it will give you a lot of different kind of gadget, and you can use their option to filter the gadgets that you're looking for. So like you can have string, you can specify the OP code. And for me, because like I just know what I want, which is to have a pop, right? So I just normally just script pop, and I will find, okay, if there is pop RDI that I'm interested in, and in this case, yes, this is the gadget that I'm interested in, right? So I can just record this. So forget about gadget. I am gonna just make it P64 followed by that value, right? That's it. Okay, so this is one way, which is to use ROP gadget. And another way is actually to use Python, use pwn tools. So I'm gonna just open the Python 3 from pwn import stuff. So pwn tools also has this nice ROP gadget like APIs for you to call. So on the right hand side, I'm showing you the right panel. So I'm gonna have a pwn. I already opened it. So you could do is you have ROP is equal to ROP followed by the binary's name, because you want to find gadget from the binary in this case. So it is baby ROP level 3.0. Okay. Okay, so it's loaded. And then you can do ROP dot, let me think. It's, oh, you can do this, ROP, and then RDI equal to the value that we want. So it's just like you tell them, hey, I want to build a ROP, and in this ROP, I want my register RDI is equal to 1. Okay, and then I can print it up, which is to dump the ROP, but also like print it so that I can see it more clearly. So then it will tell you that, hey, this is the address, right? So like this is how you look like, the stack look like. This is the address of the stack. So you have this guy, and this guy will point to this. And then this is your second element. And you may see that why the address is 4. And this is just because I haven't set the context, the architecture. So that's why setting architecture is important. So, okay. And let's do this again. See, so now it's give you the right address. Okay, so stack, the first part is, the first 8 bytes is this guy, and then the second 8 byte is hex 1. Okay, cool. And then you can use that. Also, you will get the same. Right? So it tells you that all you need to do is to put the address as the first element and then the value as the second element. And put all this together, you will be able to get the entire chain. Okay, so this is level 3. And we are going to jump to level 4. I will give you like 7 minutes because now it's 11:23. So let's start with 11:30. Work on level 4 together. And for level 4, I'm gonna purely just use the ROP API from Pwn tools. So write the entire attack using Python and using Pwn tools. And you can take a look at Pwn tools APIs, and it will give you more information. So in this level, you will realize that there is no win function at all. So you have to build the ROP chain from scratch. Then the question for you is, how can you build the ROP chain? And the hint is system call. So think about how you manage to read the flag from the sandbox module, which is to use different kinds of system calls, right? So see if you can find a system call, a syscall gadget from this challenge. And then how can you build a syscall gadget chain so that you can read the flag? let's work on this together. So I am showing a template of the attack. And now we just need to write the payload, build the payload together, and then we're going to set the payload to the challenge and interact with the challenge. Okay. So as I said, the goal for us is to use system call, right? So if you already use ROP gadget to kind of get familiarized with this challenge, right, you should already see that this challenge has a binary, has a bunch of very nice gadget, including, you know, a lot of pop, right? Like we have pop R15, R8, R9, RAX. I think there's also RSI, right? RSI, RDX, this is great. So like RDX, we have enough like argument setting gadgets that are available for us to use, right? Okay. And also there is system call, I believe, right? It's here. Okay, so we also have a system call gadget for us to use, right? Which is also nice. Then we just need to think about how to use system call to read the flag. So I'm going to show you two ways to do that. Let's start with the way that we normally do, like for when we do sandbox escaping. So like we read a file, we use the system call read to open to read the flag file, and then we use send file system call to redirect that file functor to std out. Okay, all right, let's do that. So now I'm going to just exit this. You can, I mean, in order to do that, you can use the gadget, just directly look at that address and then copy paste. But now I am going to use pwn.college functionalities. Just want to show you how you can possibly use pwn.college APIs in this case. Okay. All right, so let's have our goal. The goal here is going to be, we want to have a syscall, right? RX is 2. RDI has to be something which is pointing to flag, right? And then we have RSI is equal to 0. So this is that we want to call read. So read is system call numbers 2. So we call read followed by, this is the path of the file, right? And then this is the flag. Okay, so we read it. Okay. And then the second step is that we want to then use send file. I'm gonna just give you the actual number. You can look up the table by yourself, but now just for the interest of time, I'm going to give you all the information here, okay? So this means that I want to call send file, and I want to put, this is my destination, this is the destination file descriptor, which is std out. And then this is the current file descriptor. It should be coming from this guy, RDI, the read. And then I want to read it is the buffer of 1024 bytes, okay? So just keep in mind, this is what we want to achieve. Okay, but then there are two things that we need to pay attention to. One is that, of course, how to build a gadget chain based on this, right? And then the second is, for those numbers, since they're just, you know, an integer, we can just put it on the stack, right? It's relatively simple, right? It's just like right after each of the gadget that we already talked about. But then for this guy, we have to have a pointer that points to a location that contains the string of /flag, right? How are we going to tackle that? How can we have a place that stores string /flag, and also we know the address of the space? So keep in mind that for this challenge, it gives you a stack location, right? Which is the start of the buffer, right? So you can put /flag at the beginning of the buffer and then use that leaked address of the stack. You use that for the start of the string /flag. Does it make sense? Good? Okay, cool. All right. So let's start to build this stuff. So then we know that payload needs to be something that's gonna start with flag, right? We said that it's going to be the start of the input, right? And then followed by more paddings, and then followed by this chain, right? The first part, which is to call the system call, and then the second part, which is to call the second send file system call. Okay. Okay. All right. So then I am going to write a function that will just like generalize the generation of a system call followed by whatever arguments that I specify here. Okay. So I'm going to write this. You may find there are some special like ways that you write Python, and I will explain this to you. Okay. So I'm going to just call that ROP system call. You can, or let's put it syscall, right? Because it's going to be aligned with this function. Okay. And a args, KW args, it means that I am going to read all those arguments, but then those arguments, it has a key, which is going to be the name of the variable, okay? And then also I will have a value, right? So that means that I can use KW args as a way to know both the key and the value of the, each of the register or each of the arguments that are passed into this function. Okay, so you will see something like this for register and value in kargs.items. Right, so this is just like the Python programming way. Okay, this is all about Python. It's not really about the ROP. Okay, so now we have the rag and then we have the value. Okay. And then now we are going to start to use the pwnlib. So we want to have a ROP, and then we want to find the gadget that has the pop return that we're interested in. Okay, so we're going to have find gadget, use that API. Okay, and I'm going to put my gadget here. I'm going to just like write gadget right now and then return the address. Okay, so this is the way that you can use find gadget. So you find the address and then you use ROP.raw to convert that address to something as part of the ROP chain. Okay, so this is how the way that works. This might be a little bit confusing. Let me just make it a little bit visible. Okay, so like ROP.raw is the external function. Inside that, you're going to call gadget to find the gadget and return that address of that gadget. Okay, and then for the gadget, it's going to be a list. Each element will represent an instruction. Okay, so what you could do is you can have, say, pop RDI followed by return. Okay. All right. And then of course I want to make it more general. I don't really like RDI. I want to make the register, right? Because it can be RDI, it can be RAX, it can be RSI, it can be whatever I want. So I am going to make it as a format string. Rag. That's it. Okay. All right, so this means that I have a raw gadget that's part of the in my ROP chain. Okay, and then I will have roll again. This is the value that I want to put. Okay, does this make sense? So the first part is the gadget that will do pop and return. And the second part is the integer, is the immediate value that I want to pass it into the register, right? So in this case, I can make every register become the value that I expected. Okay, good. And then after that, then I'm going to call syscall, right? If you remember, then we need to find the places to call syscall and the return. Okay, similarly, this, but the only difference is that I don't care about pop anymore. All I care is syscall. That's it. Okay, so now we have a very nice generic syscall function, and then we just need to make the chain happen. So we can do syscall, right? But this guy, now we know where the address is, right? Now we know that this needs to be the read input address that we read from the interactive with the challenge, which is input address. Okay, and then the second is the syscall, the send file one. Okay, now we have everything. And in the end, we just put the flag, and then some paddings, and then the chain, right? So in this case, the so-called chain will be ROP.chain. Okay. All right. Does this make sense? Good. Cool. All right. So if you have any questions, feel free to ask right now. Oh, so ROP.chain will return you the byte string. The bytes that constructs, that includes everything that you put here. So it's like this is telling your ROP that, hey, I want to build a ROP, and then this is like build this step 1, step 2, step 3, like doing this all together. And then ROP chain's like, I want to dump out the chain as a byte sequence. Cool. All right, so this is how it looks like. So let me just finish this real quick. So we can have, in my case, the padding itself is it's bunch of A times. Let me see my stuff. It's all right. I hope that this just works as expected. I'm not sure, but if it's not, it's great. Then I can show you how we're going to debug it, okay? So what is called demo? Unsupported. Oh, sure, of course. Here we go. Good. It doesn't work as expected, so we need to debug it. Awesome. All right, so let's see how we can debug it, okay? So what I'm doing is that I set a breakpoint. This is at the end of the challenge file, challenge function. So you still need to reverse engineer that and then define, okay, where the challenge function returns. So this is the address that from my end, okay? And then I am going to debug it. and then just continue. Cool. Okay, so this is where the challenge is return, but now it looks like I returned to the wrong place, right? So that means that there's something wrong with my current input address and everything, right? Okay, so let's figure out where my input address is. Or let's see where my stack look like right now. Okay, stack. Okay, so actually let me take a look at my function. Okay, so I'm still in function challenge because this is right about right before return. Okay, so save the ROP is at this location, right? And then this is how to say it? So this is the address that saved the ROP, and let's figure it out where the input buffer is. I hope that I can find it somewhere. Oh, maybe it's here. Did it show it? Okay, let's check this out. Okay. It looks like this is it, but I don't see my flag. And also, I don't see my, wait, no. So this is the gadget place. Okay, this is the gadget saved RIP, but this is not the start of my input string, right? So it looks like there's something wrong with my current buffer size. Okay. All right, let's find where that is. Input address, here we go. Let's do that again. Cool, okay. So this looks about the same, about right. So this should be something about flag, right? Because this like 61, 60C, that looks like to be ASCII characters, okay? And then followed by a bunch of A's. And then for some reason, I messed up the saved the return address location, the offset between the input and the saved offset, right? So I need to figure out that. So this is the saved RIP's location, which is 6C18, and this is 6BC0, right? So let me recalculate the difference. That is supposed to be 6C18 minus 6BC0. So it is 88. Okay, so it's not hex 88. So that's the problem. Okay. Then it's easy to solve. Hopefully this is all right now. Otherwise, I'm gonna leave it to you guys to. Okay. Okay. Let's try that again. So I'm still gonna just debug it. Okay. All right, let's continue. Cool. So now it's going to jump to somewhere that is different from what we see, right? Okay, cool. So let's do jump. Now we are going to a different location, right? So we're going to different places. I think now I receive a 6F again. So there should be something wrong still with my code, but you should be able to see that this is the way that we can debug. So if we do everything properly, and after the function returns, it will go to somewhere, right? And then you can take a look at the places and see if that is like something that you expect to execute according to your ROP chain. Okay, so that's it. All right, so for the rest, I am going to leave you guys to debug. Yeah, and then you should be able to solve this challenge by yourself. And another solution, I just want to mention this real quick, is that you can also get a shell instead of like using this. Okay, I'm going to actually just show you how it looks like. I have the actual attack here. So like I am going to first show you how it looks like if everything is executed properly, like using the send file or read and send file. Okay. Read only set. I think, oh, that's because I opened it from my end. Let me try that again. Okay. Okay. Oh, interesting. For some reason, this attack didn't work also. Okay, I really need to debug it. Any case, so I just want to show you real quick then in this case. So one is to use flag, right? So use this read and send file. And then another is that you can just directly call execve /bin/sh. So this piece is correlated, and the second one, this two part is correlated with execve. You call execve system call followed by those commands. However, if you use that, you will realize that you will not be able to really pop a, well, I mean, you can pop a shell, but you cannot you cannot read the file. You will find that your permission is still denied, and you're a hacker, not the root. So it's like, although the program itself gives you the root access with the set UID, the new shell that you open do not give you the permission. So if in that case, you need to set EID again, set UID again before you're calling shell. And this is just because like in modern, like bash, dash, those kind of, shell executor, they lower your privilege again by the time that it was invoked. This is like a self-protection mechanism. However, if you set UID, in this case, it's not EUID, it's like the actual UID instead of effective user to be 0, meaning that you set UID, you set your own user as a root, then calling bin/h/bin/h again, you'll be able to get the root. Okay, and then you can do cat. So just be, just like keep this in mind. If you come across some other issue, you know why this happens, and you know that all you need to do is just like set UID ahead of time before popping up the shell. Okay.
Just A, not hex A.
Sorry, say again?
Because you're putting edges to hex A again.
Not just.
When you just try with just 88 and not x88.
Oh, I see what you're saying.
Yeah.
Let's try that. Hopefully it will work, but I mean, it previously works. I have no idea why it didn't work again. I guess maybe because my challenge got changed. So let's see. Yeah, it still doesn't work. My suspicion is that this is different from what I have. Check sum. Well, what's the MD5? Sum. Baby ROP. Okay. You see, my challenge got changed. So that's why the offset got changed. All right. But in any case, I think that they have some update of the challenge after I wrote the solution, right? So that means that some of your solution may not work again, but you already have the flag, so it should be fine. Okay. All right, that's it for today. See you on Wednesday. Oh, I'm done. You can come. Sure.